Here come examples 3 and 4 for solving trig equations. Now the difference here with these two problems is that you will need a calculator for these, as the answers will not all be automatics. For the first two examples, every answer was an automatic, but not for these. So make sure you get at least a scientific calculator or a graphing calculator out, and make sure that you are in degree mode. And this calculator is in degree mode because it says DRG down here. If it says RAD, that means you're in radian mode. And you have to use this button here, the DRG button, to shift that. If I wanted to change it to radian mode, I'd have to underline that by using these arrows, or gradients, but I want to keep it in degrees, okay? So if you're not in degree mode, make sure you get to degree mode before we start, okay? I'll teach you how to use the calculators here in a little bit, but let's get started. We start the same way we did before with these Pythagorean identities, trying to get everything in terms of one trig function. So if you look at this equation, we got a cosine here, we got sine squared there. The ones that are squared are the ones you want to focus on because those are the ones we can substitute. Here, in sine squared plus cosine squared equals 1, we could easily solve for the sine squared here by subtracting the cosine squared. So an alternate version of this trig identity would be to say, okay, sine squared of theta would be equivalent to 1 minus cosine squared theta, okay, by subtracting that from both sides. So this is what I'm going to substitute, 1 minus cosine squared for the sine squared there, okay? So first step, just make that substitution. Okay, now we'll distribute. Distribute that 3, and then organize things, bring everything over to one side of the equation and put in decreasing powers of the cosine. So this is my cosine squared term. It's negative right now. If I move it to the left, it'll become positive, and that takes care of a couple things for us. 3 cosine squared x minus the cosine of x, and then subtract 3 from both sides, you get minus 2, all equals 0. Now it's time to factor. Okay. Well, 3 is prime, so it's got to be 3 cosine of x times 1 cosine of x to get 3 cosine squared x if it's going to factor. All of these I have designed to factor, but technically they don't have to factor. You could use the quadratic formula if you couldn't factor this, but everything I write will be factorable. Negative 2 has got to be 2 times 1, where one of them is positive, one's negative. If I put a 2 there and a 1 there and make that negative, yep, I think that works. Plus 2 cosine of x and a negative 3 cosine of x combined to be negative 1 cosine of x. That's the factorization. Okay, we've got it factored. Now we're ready to solve. Set each factor equal to 0. And here we'd subtract 2 from both sides. And then we divide by 3. And we get cosine of x equals negative 2/3. Okay, hold on to that. We'll come back to it. Do the same thing with the other one. Cosine of x minus 1 equals 0. That means the cosine of x equals 1. Now, for this one, we don't really need a calculator. The cosine of x is 1. That only occurs around the unit circle. The only time it occurs is when x is 0. Remember our boundaries here. Look at the directions here. It says x is greater than or equal to 0, but less than 360. You might say, oh, 0 and 360. Well, technically you're right, but the directions here say not to include 360, so only include the 0. So this one, I don't really need a calculator to figure that out, because that's, something that we have seen in our table, and we know that the cosine of 0 is 1. So x would have to be 0 degrees there. Now, this one does not tell us that, okay? So here's what I recommend that we do. Take a look, first of all, if we did use a calculator for this one, how would we solve for that? Well, if we know that the cosine of an angle is 1, we can use the calculator to figure out that that angle is 0 by using the inverse cosine button. It's the shift of the cosine, or the second function on the cosine key. So watch what happens. If we know that that cosine of x is 1, I can say second cosine of 1, hit enter, and it'll spit out 0. Okay? Now, here's what's tricky. In this case, if I type in inverse cosine of negative 2/3, it's going to give me not all the right answers directly, because it's using the inverse key, and we have not learned about inverse functions yet with trig. So here's what I want you to do. Ignore the negative at first and just get the reference angle by doing the inverse cosine of 2/3. And then the negative, we'll just place that in the proper quadrants because we know where the cosine's negative. The cosine's negative in the second and third quadrants only. So we're going to get the reference angle first by using the calculator. Doing inverse cosine, ignore the negative at first, okay? Second cosine, and just type in the 2/3 in the parentheses there. Close the parentheses out. Inverse cosine of 2/3 is 48.189. We're going to round this to the nearest tenth of a degree, so that to the nearest tenth would be 48.2. That's not our final answer for this. That's just a reference angle, which means that's the angle that it makes with respect to the x-axis. And the cosine is negative in two different quadrants. Quadrants 2 and 3 is where the cosine's negative, anything to the left of the origin. So what we have to think about here to actually get our answers is picturing the x and y axes. Here's second quadrant, here's third quadrant. A 48.2 degree angle in those quadrants means it makes a 48.2 degree angle with respect to the x-axis. That's the second quadrant one, and there'll also be one down here. But remember, we're measuring from here, where 0 degrees is. We want to measure this angle, and this would be 180 minus 48.2. Okay, the second quadrant angle is 180 minus, I'll call it theta, the reference angle. Second quadrant is always 180 minus the reference angle. Third quadrant is 180 plus the reference angle. Okay, so our answers here will be 180 minus 48.2. Okay, that gives us 131.8. That's the second quadrant angle. And the third quadrant angle is 180 plus 48.2, which would be 228.2. So these three angles are all solutions to that original equation. So everything's the same up until the end when we have to use a calculator to figure out the reference angle instead of having it being an automatic. Okay? So one of the key things here at the end is ignoring the negative at first. Just use 2/3 when you use the calculator to get the reference angle, and then let the negative, or if it's positive, determine which quadrant it's in. And you got to know your quadrants, where the cosine's positive, where the cosine's negative, and so forth. All right, next example. Example 4 in your notes, same type of thing. This one has cosecant squared and cotangent. Well, the trig identity that has those involved is the second one, and the cosecant squared is equivalent to 1 plus the cotangent squared. So I can just directly substitute 1 plus the cotangent squared for that cosecant squared. Okay? So this will look like 6 times the quantity 1 plus the cotangent squared, x, equals 4 plus 7 times the cotangent of x. And that is going to make this all in terms of the cotangent. So I'll distribute the 6 6 plus 6 cotangent squared x equals 4 plus 7 cotangent of x. I'm going to bring everything over to one side of the equation. Subtract 4 from both sides. That leaves me with 2 still. And this is my quadratic in cotangent of x. I've got to factor this. All right, and again, not necessarily everything you're going to come across would factor, but everything I've designed here will be factorable. And you got combinations here, you got some options here. It could be 6 cotangent of x times 1 cotangent of x, or 3 and 2. Looking at the numbers, I think we can make this 3 cotangent of x and 2 cotangent of x to get the 6 cotangent squared x, and then these have to be both negative to be a positive product and make that negative middle term. So negative and negative, and a 2 and a 1, put the 2 there and a 1 there, and that works, because that's negative 4 cotangent of x, negative 3 cotangent of x, combined to be negative 7 cotangent of x. Go ahead and solve these, or set these each equal to 0. Add 2, divide by 3. You get the cotangent of x equals 2/3. Do the same thing over here. 2 cotangent of x minus 1 equals 0. Add 1, divide by 2. I get the cotangent of x equals 1/2. Now, here's an interesting thing. If you try to use the inverse cotangent, there is no inverse cotangent on your calculator. Most calculators only have sine, cosine, and tangent. So we've got to get it in terms of one of those three. Well, luckily, we know that the cotangent is the reciprocal of the tangent. So if the cotangent of x is 2/3, that means that the tangent of that same angle is the reciprocal of 2/3, or 3/2. Change this into tangent. If the cotangent of some angle is 1/2, the tangent of the same angle is the reciprocal of that. That's 2. And now we're in business. Now we can go to the calculator. And again, these are both positives, so we don't have to worry about it. But if they were negatives, you would ignore the negatives at first and just do inverse tangent of that ratio. So inverse tangent, second tangent of 3/2. 3 divided by 2 in parentheses. Close the parentheses out. You get 56.3. The reference angle is 56.3 degrees from my calculator, and the tangent is positive in the first and third quadrants. Okay? Now, if it's a first quadrant angle, it's just the reference angle itself. That's easy. So 56.3 degrees is one of the answers. Third quadrant, though, remember, is down here. It's going to be 180 plus the reference angle. So 180 plus 56.3 is 236.3. Okay? And then tangent of x equals 2. Clear this out. We do inverse tangent of 2, and that equals 63.4 is the reference angle. Okay, 63.4 degrees. And that's, tangent is positive again. It's a positive 2, so it's quadrants 1 and 3 again. So another answer is 63.4 degrees, because that's the first quadrant angle with that reference angle. And the third quadrant is 180 plus that, 243.4 degrees. These are your final answers. If you were to plug in these numbers in place of x in the original equation and crunch it out, you'd end up with the correct answers. It would be very, very close. These are rounded off, so it wouldn't be exactly right, but that's how you do it.